About to get started, so I hope you enjoyed the keynote. Amazing stuff, right? And I really appreciate it and welcome you to our session here, where we're going to be talking about how Waze takes their approach to monitoring planet-scale service with a relatively small team, how they do it, which tools they use, and what's the approach they've taken. Before we get started, I'd like just to introduce ourselves. So my name is Amir Hermelin, and I'm a product manager on Google Cloud. With me are two Wazers who actually do the work that we'll talk about, Yonit Gruber-Hazani and Evgeny Angelo, and they'll be telling about their experiences monitoring Waze. So how many of you don't know what Waze is? Excellent. Nobody. Okay, so everyone knows. That's great. That's great. And I hope you all use it. And so you know how big the service is and how people have come to depend on Waze to get them where they're going, and they depend on it to be reliable and up and available. But we'll take you behind the scenes so you can understand the complexity of monitoring and managing such a huge service. So how the service is built, how it's deployed, what kind of issues users can run into, and what kind of issues the service itself can encounter. And then we'll talk about Waze's approach to taking the data that they have and representing it in a unified manner to make it easy to automate their approach to monitoring. And we'll wrap it up by talking a little bit about the tools they use for monitoring that are called StackDriver. Okay, so with that, I'll hand it over to Yonit.
Thanks, Amir. Hi, everyone. I'm Yonit, and I've been a Wazer for the last 2 years. I'm a DevOps on Waze infrastructure team. And let's see a show of hands if you use a navigation app this week. Of course you did. We all do. I do it. I use it daily. So for the people who don't know Waze, Waze is a crowdsourced navigation app. It's free. And among our best features are time-saving routes and maps that are updated daily thanks to our 500,000 wonderful volunteer map editors who updates the maps all the time. So we currently have around 100 million active users monthly. This size of infrastructure, this size of amount of users takes a huge infrastructure to support it. So we have thousands of instances running on hundreds of auto-scaling groups. We have about 2 petabytes of Cassandra data running on 1,000 Cassandra instances, which makes us one of the biggest deployments of Cassandra in the world today. This is the amount of API calls running through our servers between the different microservices. This is a lot of activity, and it needs a lot of monitoring. So we monitor things that show us the service level that we give to our users. So we monitor the amount of traffic, that's the query per minute. We monitor the performance of the service, that's the latency. And we monitor, of course, failure rate. So when you have such a big system and you help people with their driving, downtime is not an option. When an online game is down, people are annoyed. I know when my son's online game is down, he's devastated. But when Waze is down, people get lost. So in some countries, when Waze is down, within minutes, it's in the news, in the national news. That's how essential we are. So try to imagine that you're a DevOps on the infrastructure team. You're trying to debug a problem at rush hour, everything is failing, and reporters are calling you to ask details about what's going on. That's a very stressing situation, and we've been there. So downtime is not an option, but downtime happens. And I use Waze every day when I drive home. I want to know how much time it's going to take me to get to the school to pick up my kids, so I can call ahead and beg for mercy from the teacher. So we feel responsible to keep our system online all the time. So now that you understand the size of the challenge and what we need to monitor and how big it is, let's take a look at the technology stacks that actually we use at Waze so you can see how we carry this amount of traffic. Waze is built on microservices. We use Java-based code. We run on standard instances that are part of an auto-scaling group. We use Redis or Memcache as a caching layer, and we use Cassandra or Postgres as the databases. Now, most of our services are pretty similar, they look the same, but we have a few outliers. Some are not Java-based, and some are not even running on instances. We use as well Kubernetes and App Engine and Cloud Functions. Now, these hundreds of microservices, they're talking to each other. Sometimes they're servers and sometimes they're clients, but most of the time they're both, passing data between them with API calls. So to do that, we use a proprietary communication protocol. And this protocol also collects statistics about these API calls between the different microservices and sends them into a central location. So we have a place to pick up all the statistics about the performance and usage of these APIs. Our production critical servers are also split into dozens of geographical shards. Now, why is that? Because it helps to spread the load between the different areas, and it reduces the impact of bad updates when we deploy code into production. Now, seems pretty complicated, doesn't it? Well, you haven't heard the half of it. This is only on one of our logical data centers, bless you, split across 3 regions. And that was only the front-end part, the online part, which has the actual user experience. We also have an offline part, which is doing the machine learning and map building. And we use big data tools to do the post-processing. We use MapReduce and Athena, and everything needs to be monitored. Oh, and double everything I just said because we use both GCP and AWS. To support deployments to these 2 different clouds, we are using Spinnaker open source to deploy our code. This gives us an abstraction layer between the clouds and allows for seamless management of GCP and AWS. So what we see here in this specific slide is a sample of a microservice that does routing. You can see on the right hand that we have 30 and more API calls that it's using to talk to about 5 microservices. And on the left side, you can see the scale. You can see all of this is in one of these rectangle on the left. So you can see the size and the amount of the API calls. This is what brings us to this staggering number of 25 million API calls per minute. On top of monitoring such a large-scale infrastructure, there are other things to consider when monitoring. We have new features. We have hundreds of engineers working all the time to extend our system, add new features, and deploy new microservices into production. These needs to be added with monitoring on the fly without interruption and with zero config from the developer side. There are hardware failures. Imagine we have thousands of disks running around in the system, and as you all know, disks fail. This is something that they do. So we need to monitor that as well. We have quotas. When you use a cloud service, you always get to the 100% of quota usage on any given API at 3 a.m. in the morning, usually. So we want to alert on the 75% of the quota before we get there, so we have time to increase it and request for more, because you all know that takes time as well. And certificate and licenses are also something that expire within a large infrastructure. So we want to be alerted 30 days in advance so we can request for extension or replace those certificates with a new one. And of course, service SLO. Every service that we monitor, we want to know the quality of it. So we need to know QPM, that's the query per minute, failure rate, and latency for the performance. And of course, don't forget about the scaling. This whole thing is very dynamic. Imagine that we have the geographical shardings, and each country has a different driving hours and driving habits. And you have holidays. Any auto-scaling group can grow from 3 servers up to 120 throughout the day and shrink back at night. You can't monitor something like that with configuration files. So now that you know how complicated it is and what are the challenges, can you imagine how to start deploying a monitoring service on such a large-scale system? Ladies and gentlemen, I present to you the man behind the machine, he who brought order out of chaos, the Python ninja, Evgeny Angelo.
Thank you, Anit. Hi, everybody. I'm Evgeny, and I'm going to show you how StackDriver makes sense of our complicated system that Anit just told you about. Firstly, it wasn't stable enough, and it took us a while to find out when it was down. Secondly, monitoring new microservices in our system was complicated and time-consuming, which was a big problem because new microservices were being added constantly, and we were having trouble keeping up. About 2 years ago, we heard about a new monitoring system called StackDriver. StackDriver offers powerful tools for collecting and using time series metrics. We thought it was pretty cool because it was easier to see the status of an issue over a long period of time. StackDriver automatically collects metrics from our GCP instances and services. It can also import the data from AWS CloudWatch with just a few clicks of a button. Thanks to this, we hit the ground running and got tons of useful info without any effort on our part. The built-in metrics were great, but we also needed another type of metrics. And StackDriver allowed us to send custom metrics with all info we needed. It's a really flexible system with great functionality. We also found out that using their API was super easy and the system was very stable, and it could process a large amount of metrics quickly. We realized that with StackDriver, the sky was the limit, and we started adding new metrics from all the various corners of our system. For example, we started writing metrics like request rate and latency and gave them labels according to their cloud platform, region, and more. So that way, you could see in one metric information from instances running on both AWS and GCP. After we added all this data into StackDriver, we started thinking about how to put it to good use. First of all, we wanted to make it more easily accessible for us and for our developers. And we did that by using Dashboard API to create specific dashboards for all our critical services. They basically allowed us to display a lot of useful information, both built-in and custom, for even any given service in a single pane of glass. Second, we wanted to be alerted when specific metrics meet predefined conditions. To accomplish that, we started using Alerting API to create alert policies, which basically allowed us to define one or more conditions that will trigger an alert and define how the alert will be delivered using notification channels like webhooks that can report a bug, page the on-call, or trigger our auto-hitting actions, which allow our internal scripts to try and fix the issue before we wake up the on-call. Over time, we added even more metrics such as failure rate, cache and database layer state, errors, and plenty of client-side metrics. We could also use the data that already existed in StackDriver to compare our current state to the state we had last week or at some other time in the past. This helped us find anomalies and other irregular activity which had previously been next to impossible. For example, let's assume that we usually have about 10,000 logins per minute in the Bay Area during peak hour. And today, that number is 10 times higher. This could point to a real problem like a login retry storm, and we need to be able to see that. Now let's talk about automation. After a period of using StackDriver, we thought that a lot of our service dashboards were very similar. So we thought, why not automate their creation? And we did that using a schedule process that scans for new services in our system and automatically creates a dashboard using predefined templates without any additional work for us or the developers. You have no idea how much time it saved us. It also reduced the time it takes us to find the root cause of issues and resolve them, because all the dashboards are created using the same template. The schedule process also creates alerts for new services with default threshold and notification channels. After a learning period, we adjust them so then they actually notify the on-call when there are any issues. Both dashboard and policies definitions, whether manually or automatically created, are saved in the Git repo and can be modified by the developers. And any developer working a new service can add themselves as a notification channel and debug the issue before the service moves to production. Everything we just talked about helps our team sleep better at night, with less false positive and resolve issue faster. Okay, now I'd like to show you a demo based on an issue we had in the past that was solved quickly and easily thanks to StackDriver. All right, so let's say that I'm currently on call, it's the middle of the night, and I just got a page on my phone. I can see that it's a page about a high failure rate for one of our routing services. So I wake up, open my laptop to see more information about the alert. In the email, we can see a link to open incidents, to our playbook, and the link to the dashboard. In the bottom, we can also see the resources that triggered the alert. Before I move on to the dashboard, let's look at the configuration of this alert. We can see that it's pretty easy to read. Any developer can easily modify the notification channel's duration or threshold if needed. The combiner allows me to choose whether to trigger the alert if all the conditions are met or at least one of them. In the notification field, we can choose one or more. For example, we can see that in the example, we can see that the alert will send an email and trigger our webhook that will call auto-healing bot with the details of the incident. Okay, this is a dashboard that was linked in the email. The problem can be seen in the server API failure rate widget. Now I filter the metrics in the widget to focus on the specific metric related to the issue. After scrolling down a bit in the dashboard, I see something interesting in another widget, displaying service dependencies failure rate. And by dependencies, I mean all the services that routing needs to function properly. I see that geocoding has a high failure rate that started at the exact same time. So I go to the geocoding dashboard and see something weird in the Cassandra latency widget. Read latency peaked just before our routing issue started. So I connected to our Cassandra cluster and manually fixed the issue using our Cassandra playbook. In the future, this issue won't even wake me up because we are very close to finishing our Cassandra auto-healing process that will fix it automatically. So, as I just demonstrated, StackDriver gives great visibility into our system and helps us resolve issues much faster than before.
Thanks, Evgeny. Okay, so we have hundreds of engineers working all the time on improving a system, adding new microservices, and extending the existing ones. Before we had all these automation tools that Evgeny just spoke about, all of this was done manually in the DevOps team. So at some time in the progress, we just couldn't keep up with the workload. And large parts of the system were inadequately monitored, and some parts were not monitored at all. So let's take a look how it looks now with all the automation in place. let's say that I'm a developer at Waze, and I just wrote my new cool microservice and deployed it into the staging area. Now, I use the Java microservice framework that all the developers use in Waze. And this framework includes our monitoring modules already written, and it will start working automatically. Those modules, I'll tell you a little bit more about these modules. As you can see from the beginning, this dashboard will be auto-generated and auto-deployed into StackDriver with the StackDriver dashboard API as soon as I deployed my service. And I'll show you each of these cubes because it's very little. So the first thing that we'll see are the server APIs. These are the same APIs that I've been talking before for the specific service that I'm looking at. And I will see query per minute, and I'll see server failure rate, and I'll see also the latency. You can see on the right side, in the right upper cube, also server diff for the API. This is the QPM from last week. So we can see a comparison and see if there's a change in the behavior of the application. The next set of widgets are the server exceptions. Now, this is from the application log. We collect with those included modules inside of the Java framework, we include all the errors from the log, and we export them as a graph in the StackDriver. So I can see from the same dashboard how the application is performing. Now, the client APIs is like what Evgeny told before. These are the clients that are connecting to my microservice. So I can see as well how they are performing also in the same dashboard for the microservice. So I can see how my service failure is affecting other service in Waze. And the last set here are the dependencies. So my server is connecting to other microservices. And we can see here the QPM, the query per minute. We can see the timeouts, and we can see the errors for connecting to other services. So I can see from this dashboard if the problem is actually in my microservice, or maybe it's downstream in a different microservice. So I can continue going between the microservices until I get to the problem one. Also, we can see here from those included monitoring modules, we can see that the memcache QPM, query per minute, is showing up. All the data layer is also exposed in the same dashboard, so I can see if the specific service is having a problem with a memcache or with the Cassandra it's connecting to. I can even see which table is eating up all the space. So these metrics are great, but they're not enough for my particular use case. Let's say that my microservices is also writing and reading from a queue. So I want to see what is the QPM of writing messages to the queue. Now, my application already exports these metrics, and they're already in StackDriver thanks to the included modules. But I want to see it on the default dashboard. So what I need to do is edit one configuration file from our StackDriver configuration repo, which is saved in Git, push it into production, and that's it. In a couple of minutes, Evgeny's automation tool will pick up on the change in Git, and we'll add that widget via the StackDriver dashboard APIs into the dashboard that I'm using. As a developer, I can also open a new config file and create a whole new dashboard only with the metrics that I want to see when I'm debugging a problem. All these changes and repeating dashboard structure helps me at 3 a.m. to solve production issues. I can tell which table in the Cassandra is failing. I can see exactly what the problem is from the logs in the same dashboard. So instead of just getting like an alert, Waze is down or the website is down, I get an alert saying service A is failing, and in the dashboard I can see that it's failing because of service B, which is downstream, a dependency that is not performing well. Looking into the future, we are using Spinnaker open source to deploy our services. So now we are starting to integrate the metrics from StackDriver into the Kienta tool, the new Kienta from Spinnaker, that will take these metrics, and when you're doing a deploy, it will fire up a few instances and do a comparison of the metrics between the new instances and the older auto-scaling group to decide if to move forward with the deployment or to stop and kill those instances and roll back. So this way, the deployment process is automatically deciding if to continue and no human intervention is needed. This, of course, will reduce downtime if a bad deploy is done. So this is me and my league of extraordinary gentlemen. We are mostly DevOps and a few developers. And this tiny DevOps team handles this whole operation and its uptime. We have one on-call for primary issues and one person who wakes up at night, and one secondary to handle the bugs that the StackDriver notification channel can open. And where are we today? We are sending 2.5 million time series per minute into StackDriver. We have thousands of dashboards, all created automatically through StackDriver, dashboard API. We have hundreds of policies all set up on the critical time series, so we know when something is failing. And now I'll hand you back to Amir, who will put everything into perspective.
Thank you very much, Yonit. Thank you, Evgeny. Yeah, so the next time you use Waze and you're kind of thinking, how does this work, keep working, myself and hundreds of millions of other users, now you know the story. This is the team. Other members are lined up also, if you can recognize them from the photo. So that's the story of how the approach they've taken. But let's talk a little bit about StackDriver, which is the platform and collection of services that they use to enable this monitoring approach. So first of all, what Yonit and Evgeny described is how they use StackDriver, and we focused mostly around monitoring. So StackDriver is a platform that enables you to easily collect metrics, logs, and other data into a central repository. They take that from open source components, from applications that are running in Google Cloud or AWS. We use APIs and other methods to ingest. Yonit did mention the dashboard API, which is currently in early access. We intend to release it in the future, but it's not available to everyone right now. But the alerting API, as well as other APIs mentioned, is available. And then you take that data. First of all, StackDriver enables you to store it, to maintain it for longer periods, and to create visualizations and insights from it. Visualizations in the form of dashboards. Insights are sometimes automatically inferred from the data and the correlation, as well as generate alerts via our various notification channels. So Evgeny mentioned email and webhook. We support other channels such as PagerDuty, Slack, SMS, etc. And we are expanding our support for that. And finally, StackDriver also supports other third-party vendor ecosystems, so you can integrate with other tools that can use this data, and other services in the cloud. One example being taking logging data and automatically ingesting it to BigQuery for deeper analysis. Just to complete the picture, StackDriver is not only about these capabilities, we're building more. So we're building context capabilities and auto-inferring of services. We're expanding more of our visualization technologies, adding tools that can help you better mitigate issues and deal with incident response, etc., etc. And you can hear about it in other lectures as well. And just going over the different StackDriver products available to you. So we mainly touched upon monitoring, which you can use to visualize and alert on the health of your application. StackDriver also has a logging product that collects your logs, in some cases automatically, depending on the service, and lets you analyze them and do fast queries, and even do things like create metrics from logs, so you can use those metrics in dashboards and alerting policies and other advanced capabilities. We also have error reporting, which can automatically group and detect and alert you on exceptions and failures in your code. And again, the nice thing is that the suite is tightly integrated. So let's say you already have logs in the platform, then error reporting comes from free. You don't need to instrument another service. You don't need to sign up for something else. It's automatically available for you. We also have trace with distributed trace, which we support via API, SDK, Zipkin collectors, and it automatically collects trace and analyzes your latency for applications running in App Engine. Debug is another very, very useful tool that lets you debug applications in production. So you can, during production, you can insert breakpoints and logging statements without all the overhead. So you don't need to instrument it in advance. It's a really cool capability, and I hope you can see a demo of it in one of our sessions here. And finally, Profiler, which is it's actually in beta. And so it's available, and it helps you pinpoint hotspots in your in your applications running in the cloud. Okay, so to recap it, firstly, how many of you are running services that you believe are larger scale than Waze? Nice. Which services? Okay, Spotify. Yeah, that's a huge service. That's great. Love it. I was hoping at least one person would raise your hand. But for the rest of you, this also applies to you. This approach can also apply to you. So let's recap what we talked about today, right? We talked about how large the service is and how challenging it is to monitor it, and what are the implications of not catching errors real time, right? What it means to users. In the case of Waze, it can mean people not reaching their destinations on time or at all, or it can be even, sometimes it can even make it to the news in some countries. So downtime is definitely user pain, and the team that is tasked with keeping the application app, it's not a huge team, so they need an approach, right? The system is very dynamic, which creates more challenges. So any developer can add microservices, remove microservices on the fly. They don't need to check in with this team, right? And it can be developers in different floors or in different buildings. So the approach the team has taken is, first of all, to decide which metrics, which signals they collect, what do they look at in a more canonical way, right? For all the microservices, what are we interested in? What metrics, what dashboards, what alerting policies? They started there, right? After that, they fine-tuned because, different microservices have, different requirements, so you can build and customize. And when you have that kind of canonical approach across the board, built in as much automation as possible. So, the developers use config files and the alerting policies and the dashboards and the metrics that are ingested. Everything is automatically generated to reduce human error and also to promote unity. So when problems occur, engineers can look at different microservices in the same manner, a similar pane of glass. So automation is a key part. And lastly, we talked about the specific monitoring suite of products that Waze uses, which is StackDriver. StackDriver is available free to try. Just Google StackDriver and get started. Just lastly, other talks. I'm not going to go over each one, but these are talks related to monitoring, to SRE best practices, to how Waze and Spinnaker, Waze uses Spinnaker together. These are all great talks. We recommend that you attend them either today or the next days. And don't forget to rate our session, especially if you liked it. So looks like we have a few minutes, but we are standing between you and lunch. The only worst thing is standing between you and beer, but we are standing between you and lunch. So what we're going to do is we're going to wrap it up here. But if you have additional questions, we're going to just be right here next to the stage. Feel free to line up and come ask us. The rest of you enjoy lunch and the rest of the conference. Thank you very much. Thank you.